Good day, everyone. Thank you for being here today. My name is Nur Alamsyah. I will present about our research on improved prediction of global temperature via LSTM using ReLU activation and hyperparameter optimization. This work conducted by myself, Nur Alamsyah, Budiman, Acep Hendra, Elia Setiana, Titan Paramayoga, and Venia Restreva Danestiara. So for first section is about our background. Global temperature prediction are important in the context of significant climate change for disaster risk mitigation and adaptation policies. Temperature prediction requires sophisticated approach to analyze heterogeneous and high-dimensional time series data. LSTM is a type of neural network architecture that can understand and model temporal relationship in sequential data such as global temperature data. And for our problem, about key issue is global temperature prediction are important for climate research and disaster management and environmental planning application. And for our challenges is the complexity of the climate system makes accurate temperature prediction difficult. And our literature review, previous studies use linear regression models, statistical analysis, and machine learning techniques such as ANN and ARIMA. So our limitation is many of these models fail to capture the nonlinear nature and complex temporal relationship between weather variables. And for related work, recent research highlight the potential of using more complex LSTM models to improve the accuracy of global temperature prediction. So our gap is more sophisticated approach are still needed to address uncertainties and complex fluctuations in global temperature. So this is our proposed method. First step is data collected, and then data preprocessing, feature selection, and we divided data into two parts, data train and data test. And then from data train, we develop LSTM model. And we using RMSA for evaluation, and for last step is result analysis. So for first step is data collected. The total dataset we use consists of 37,040 and 425 data entries and 41 features. This dataset consists of weather information from various countries. This data was obtained from secondary data source through the Kaggle dataset portal, which is one of the most reliable data source available for scientific research. And for second step is data preprocessing, missing value checks, transformation of last update features or columns, and data validation. Missing value checks, data is checked to ensure there are no missing values, ensuring the dataset is complete and ready for future analysis. And for transformation features, the last update column was transferred to date and time format to ensure consistency and ease time manipulation in data analysis. And data validation, all data was checked for suitability and validity to ensure that the data used was consistent with the predefined format. And for feature selection, we using Pearson correlation technique used to evaluate the relationship between the independent variable and dependent variable. And we choose temperature Celsius as a dependent variable. So a feature with correlation value of more than 0.5 or less than minus 0.5 with temperature Celsius as a dependent variable were selected for future analysis. And for train and test data split, the dataset is divided into 80 and 20% data. 80% for training data and 20% for testing data to ensure the developed model can generalize well to data that has never been seen before. And this is about LSTM model development. We have several steps. First is loading the dataset, selecting relevant features to use in prediction, and defining target variable, temperature Celsius, as the target variable or dependent variable. And we divided data 80 and 20% proportion for training and testing data. And then reshaping data, adjust the input needs of LSTM model in three-dimensional form, and then using LSTM layer with 50 units and ReLU activation function, followed by a dense layer with 1 unit. And for hyperparameter tuning, we using Adam optimizer and mean square error loss function. So for model training, using a certain number of epoch and batch size while monitoring the model performance with validation data. And for model evaluation, we using the root mean square error metric to assess the model ability to predict temperature on test data. So our evaluation, we using root mean square error as the main metric to measure the prediction quality of our model. The lower the RMSE value, the better is model is producing accurate prediction. Therefore, a low RMSE value indicates that our LSTM model is able to provide global temperature estimation with high precision based on selected feature. And this is our result. We compare LSTM with ReLU and hyperparameter tuning and LSTM without ReLU and hyperparameter tuning. And result of LSTM with ReLU and hyperparameter tuning is RMSA 0.0465, and result of LSTM without ReLU and hyperparameter tuning, we get RMSA of 0.1423. So our conclusion about our comparing using ReLU and hyperparameter tuning improve the accuracy of the model significantly. So this is our learning curve evaluation. The learning curve show a decrease in loss on both training and validation data. So indication the model continues to learn and improve its performance, although there are indication of mild overfitting. The slight difference between the training and validation loss indicates that the model might start overfitting slightly, but the performance on the validation data remains good. And this is a graph about actual versus predicted temperature. Prediction versus actual graph. The result is the graph show that the prediction patterns tends to follow the actual data pattern well. And there are slight difference between the actual and predicted values at some points. And this is our discussion. We compare with another studies previous, like Esparza et al., Olochak et al., Jun et al., Go et al., and Amri et al. And if we compare for their work or their research, our study is better for RMSA evaluation. And advantage of proposed method, first is ReLU activation. Help the model learn more effectively from complex data. And second, hyperparameter tuning. Better adjust the model parameter to the training data, improving the overall performance of the model. And so the last results, the use of ReLU and hyperparameter tuning result in more accurate and reliable global temperature prediction. So our conclusion is first about a significant feature selection. We selected 4 key features with significant correlation to Celsius temperature, temperature Fahrenheit, feel like Celsius, and feel like Fahrenheit, and last latitude features. So our model evaluation result is ReLU hyperparameter tuning better than ReLU without ReLU and hyperparameter tuning. And for our future research is first about inclusion of additional features. Incorporate more features that may contribute to global temperature prediction, such as additional weather data or other environment factors. Exploration of other deep learning technique, employ other deep learning technique, or assemble model to enhance prediction performance. And analysis of nonlinear factor, conduct future analysis of nonlinear factor that might affect global temperature. So this is our research contribution. This study or this research provides a strong foundation for future research in developing more robust and accurate temperature prediction model. Highlight the importance of applying advanced machine learning technique in climate prediction with practical implication across various fields, including agriculture, energy, and disaster mitigation. This is our presentation today, and thank you.